Area. Oh, we love area. We've been doing area since when? Like first grade? So today's lesson is not really to tell you about how, like what the area formulas are. Today it's more of a, do you know where these formulas come from, how we derive them? Basically, they all start with the rectangle. And probably when you started doing area of a rectangle, you did it on a grid. So you could count the boxes. So you counted how many went across the bottom, call that the base. How many went up, call that the height. Because it's a right angle, we know that the area of a rectangle is base times height. So knowing that formula, what we're going to try to do is we're going to try to figure out the area formulas of some other ones as well. And we'll start first with the parallelogram. So as you see here, I've got a parallelogram. Now watch what we can do. The cool thing about a parallelogram is if you make a slice perpendicular to the base, you can then put that piece on the other side of the figure and you can make yourself a rectangle. That's a really cool thing. And that's why the area of a parallelogram is base times height, because we can make it into a rectangle. So I'm going to go back here. I'm going to say the area of a parallelogram is base times height. But again, let's be aware that the height always makes that right angle with the base. Okay, so the height is not necessarily a side of the parallelogram. If we keep rocking and rolling, we go to the triangle. Notice in my gray triangle here, the dashed line, that represents the height of the triangle. So watch what we're going to do. We're going to do some transformations. Ah, don't you love it? A 180-degree rotation centered at the midpoint of one of the sides. So what shape was made? Yeah, can you tell that we made another parallelogram? Gotcha. So the area of a parallelogram is base times height. But remember, the triangle's area is only half of that. That's why the area of the triangle is 1/2 base times height. Let's throw that in there. Area equals 1/2 base times height. And again, remember that the height always makes a right angle with the base. Cool things. All right. Wait till you see the trapezoid. You're going to love it. Check this out. So here's my trapezoid. And let's talk about what that might be. Let's press run and see what happens. Ooh, what shape was made? Yeah, we made another parallelogram. So we know what the area of a parallelogram is. The area of a parallelogram is base times height. But notice that the base are different in a trapezoid. So after I flipped it around, I put base 1 down there and base 2 up there. So the base of the entire parallelogram is base 1 plus base 2. The height hasn't changed, but because it took us 2 trapezoids to make a parallelogram, that's why we have the 1/2 in front of that. Pretty neat stuff there. So the area equals 1/2 the sum of the bases times the height. Cool things. We'll draw one. We'll call that B1. We'll call that B2. We'll call that H. Nice. Make it a right angle. Cool things. Ah, but wait. There's more. Suppose we want to find the area first of a kite. What the heck would that be? I mean, here's a picture of a kite, right? Maybe you notice that there's like a 90-degree angle somewhere in the middle here. So maybe you can find some triangle areas. Yeah, some good things there. So check this out. Whoa, that was like super duper quick. Let's reset that and show it one more time. So what's going to go on here is I'm going to flip over that bottom half of the kite. And then I'm going to slide it up. What shape was made? Cool. And we know that the area of a rectangle is base times height. But if we think about this here, I'm going to draw it on this one here. Okay, my base is really the length of that long diagonal. And the height is the length of the other diagonal. Well, not the whole diagonal, but half of it. So that's where our area formula is 1/2 the product of the diagonals. That's pretty cool. So when I erase some of this stuff here and I reset it, come on, let's hit reset. There we go. Slide that baby down. There we go. So it's half the product of the diagonals. You didn't know that one, so that's pretty neat. Let me see if I can draw myself a good-looking kite. That's horrible. Stop. Redo. Hey, here's a little trick when you draw a kite. I like to do this. I draw that, then I draw that. There we go. So D1 and D2 are my diagonal lengths. Yeah, cool. Now, you might be thinking, dude, that kite was cool. You ain't seen nothing yet, man. Let's talk about the area of a circle. So what we're going to do for the area of a circle is we're actually going to slice it up. So right now my circle has 4 slices. I can change that maybe to like 8 slices or 12 slices. I'm going to slice it like, you ever go to like a little kid's pizza party? You know, they've got like 32 kids there, so they make like 36 slices of pizza and they're all like super duper skinny. I'm going to do that. And then what I'm going to do is I'm going to unwrap it. Check this out. When I unwrap this, and then I'm going to take this piece and I'm going to stick it right in there. Whoa! What shape was made? So the idea here is that this shape is really a rectangle, because remember, if I was to draw in the height of it, the height is going to be perpendicular. Now, the height turns out to be the radius of the circle. So if the height is the radius of the circle, and the base, it's not really like, I'm going to exaggerate a lot, it's not really like a straight line, it's kind of like a bumpy road. But what that figure is it's half of the circumference. Do you remember that circumference of a circle is pi times the radius times 2? So if I take half of that circumference, I get pi times radius. So my base is equal to pi times r. My height is equal to the radius. And because I have a parallelogram, the area of my parallelogram is the base times the height, which is pi r squared. How cool is that? Wild stuff. And what was nice that we also threw in here was a little circumference also. So I'll throw that down too. It equals 2 pi times the radius. Friends, amazing things today.